Well, let's get started. 1 o'clock. A couple of things before we start is I posted assignment number 4, due a week from Thursday. And it's basically doing an analysis of your Schneider Hall project in terms of quantifying the programs and spaces and how many students that works out to. So it's mostly in Revit and then a little bit in Excel at the end, but good practice of getting information from one program to the other. And I'm setting that up for the first time in this class as a group project, since you're already in groups doing that. And we'll just have divine you to join one of your groups for the purposes of this. And I don't know how you want to divide that up. I think it would be good for everybody to have experience doing all stages of the process, but y'all can figure that out for yourselves. But I think it's a really useful workflow to understand how that works, getting information out of one program into another. And this is a pretty clean way of doing it. Today, I want to address lighting in Revit. The gist of it is, as we will see, is Revit has a couple of ways to create and use light fixtures that reasonably approximate what real light fixtures do, but there's just a lot more complexity with the physics of light that a program that's basically made to put buildings together just doesn't have in it. So we will explore Revit's strengths while acknowledging its limitations. The next assignment will be creating a light fixture on your own, maybe one that would fit into the Schneider Hall project or just one that you would like to have. Before we can deal with light fixtures, we need to understand some things about ceilings, since so many light fixtures anticipate a ceiling to be in. I'm just going to make a room, put a floor and a ceiling in it, door and a window and some furniture, and then use that as sort of the test bed that we use here to understand how the different kinds of fixtures work, how we can turn them on and off individually and change their brightness and stuff. So just in my level 1, I'm going to go wall, and I'll just use the chipboard wall because it's got a nice light finish as opposed to some darker gray one, 4 7/8. And I'm going to put a floor in it. One of the reasons I'm doing this is we'll be rendering this a bunch. If there's no floor, light sort of from underneath, from the sky below, which is very, very disconcerting. So floor, architectural. Let's go to ceiling plan and put in a ceiling. Okay, let's just use WT for window tile, ZA to see both of these. And for reference, I'm going to put a window and a door in here. Window, any old kind of window. Door, any old kind of door. And I think some furniture. If you would like to be able to locate lights over these desks in the floor plan, it's a little hard to think, I have to come over 4 feet 3 and then down 8 feet 2. So in the ceiling plan view, where we're going to end up placing most of the light fixtures, we can turn on the underlay to show the first floor level and that we're looking down at it. So then we see this furniture lightly dotted in underneath. And it might be you want to move the furniture depending on where you put the lights. Right now, I can't select these guys. They just don't show up. But over here, if you click select underlay elements, you can tab over to select it and move it here in the underlay, and then it shows up here. I'm going to turn that off just to not to get myself too confused. I also want to add a second floor to all this. Go to level 2, create a floor, and this time I'm going to use, I think, the concrete floor, 12-inch generic build floor, level 2 plan. So what we have in section view, section, is a room with a ceiling and a floor above. And the important part of recognizing this, of having these two, is that in most commercial situations, offices, hospitals like that, the actual floor is 4 or 5 feet above the ceiling. Below that, you've got the floor slab, you've got joist, you've got duct running through, and a bunch of the Revit light fixtures are made to attach to ceilings, actually attach through ceilings. When you create them, you use the light fixture ceiling-based template, which includes the hole to cut through a non-structural ceiling. What's above our heads in LL25 doesn't count as a ceiling as far as Revit's concerned. This is a 10-inch structural concrete floor. We're not drilling holes in it. And if we wanted to use some of the fixtures that need a ceiling to attach to, we would have to put like a thin ceiling up there and attach to that. As we'll see, that gets to be a pain. Some things can just attach to a face. So they can stick on the ceiling, they can stick on the wall, they can stick on the floor, they can stick on the side of a desk. They just need a surface to attach to. But the ones that are set up for ceiling, which is mostly the recessed cans and all the troffer fixtures that anticipate a rectangular ceiling grid to lay into, those will really only go into a ceiling. Some of the pendant light fixtures are made to attach only to ceilings as well. And ones from Revit City, you have no idea how they work. Some of those, you just tell how far off the floor you want it to be, and then you just nudge it up until it seems to be in the right place. There are a couple of other reasons why we need ceilings as separate objects from the floor structure. This floor structure is continuous through the entire building, whatever that is, 10 or 12 inches of concrete. But the ceilings can vary. I mean, if we were going to dress up this ceiling, we might end up having a layer of gypboard glued to that, and that would become the new ceiling. In the chair's office, those are drop ceilings with panels in it. They're probably 8 feet below the actual structure of the roof. A ceiling might be curved, it might be slanted. So in Revit, as well as in the real world, each room or each large space gets its own ceiling. Okay, let's look at different fixture mounting options. In the real world, surface mounted fixtures, of which there are now a great many more now that LEDs have come into play. It might only be this thick, and it can, we can stick something there that looks almost flat, looks like a recessed can fixture in terms of just sort of a disc and maybe this deep, but it's the whole light fixture itself right there. Put some of those in a kitchen a couple of years ago, 2 years ago, and it was really great because we didn't know where the existing ceiling joists were. And I didn't want to have to cut those away, and I knew exactly where I wanted the light fixtures to be. So instead of a can fixture that would have to go up and fit in the space between two joists, I could just put that on the ceiling. It could be anywhere it wanted to be. And they're much easier to renovate. You don't have to go up into the ceiling for them. So surface mounted fixtures, let's take a look at one of those. If we go for a surface mounted fixture, which is architecture, component, place component, load family, lighting, architectural, internal, meaning interior, just like this downlight round LED, pretty much all the ones that say LED in them are implying that they're not going to be recessed. They just have a thin disc of light emitting diodes. And so if we pick that one, round LED, it said surface mount, right? I can truly place that anywhere. I can place it on the wall, place it on the ceiling. It's just looking for a surface, any surface. We can place it on the side of a desk or the front of a desk, just looking for a surface or a face, and that's controlled up here. Placing on the work plane is usually the floor, just by default, unless we'd actively said, no, I want this wall or this side of something or other to be the work plane. But as a rule, place on a work plane means the floor. So we had place on face for some of these as an option. A couple others like the troffer lights, which are the ones that drop into a ceiling grid. And the way the grids are made is usually across the short direction of the room, you install the structural main T's, T-shaped thing, upside down T, that runs from one side of the room to the other and is held up by wires every 4 or 6 feet. And then between them are clipped 4-foot long cross T's. And into the resulting 2x4 or 2x2 foot spaces, you can drop a ceiling tile or other panel, HVAC diffuser, or light fixture, like these 2x4 foot fixtures that we're about to load. Component, place component, load family. These troffer guys, let's see the 2x4 foot one, open. And then here we are on the lighting plan. And when these drop, they not only locate themselves in space, but they understand their relationship to the grid as well. So once we sort of click this in here, and I don't know how close we have to get it, but all these line up nicely. And then when you select the grid and move it, the lighting fixture goes with it. You'll notice that this guy he doesn't know that he's on a ceiling. He just knows he's on a flat face. So anyone like that, you'd have to bring along separately. The recessed can fixtures work the same way. Component, place component, load family. Let's say recessed can, just this straightforward recessed can fixture, which are typically like 6 or 8 inches in diameter and usually 8 or 10 inches deep. These know where they are in relationship to the grid as well. So they'll move along with the troffer ones. So you can see they give us some light, but not much. I've got a little bit of a glow here from this guy. This one is lost here. These two are still picking up a little bit of sort of test lighting on the desk. But now watch what happens when in section, I move this floor down. So it's just a tiny bit above the ceiling that's in. Go back to here, RR. And you can see we're not getting any light out of those fixtures at all. And what's happened is once you start looking at that family of the recessed can fixture, and I bring this up just because it kills people every semester, and you might as well just know about it ahead of time, is in section, the light fixture itself is sort of like this, with this whatever ceiling is coming in here, and it will cut the hole for the light fixture to go through the ceiling. So the light source shines out onto the floor. And what happens when you put concrete here, that light source, which has a physical location, is actually inside concrete, and it figures, well, I'm not shining anywhere. So we need to make sure, and you really do in the real world, if you have anything like this situation, either you don't specify recess fixtures or you leave room, at least a foot to get the light fixture in. So let me move this back up. And let me just show you that light fixture and go to Edit Family. And then look at that in a true elevation view. The yellow is the light source itself. And anything that's solid below here, anything that's sticking into, whether it's a floor or a wall or whatever, will keep the light from shining out. Okay, so that's up there. So now these guys are safe. Now let's go back to the 3D view. And we'll render that again. And as you can see, it's still a pretty dim room. And that's because these are like 60-watt bulbs, which are just not going to cut it at all. So if we select this light fixture, and go to Edit Type, and the type includes all of these guys. Go to Edit Type, and then all the way down at the bottom of Edit Type for light fixtures is the initial intensity of the bulb. And that was 60 watts, just sort of based on incandescent. We're not into LED or anything at this point. Let's see what they are at 200 watts, which is about as much as you can put in a can fixture without it melting. Okay, so we can adjust the intensity. And when you're doing these test renders, just to sort of get things right, the amount of time that it takes is based on how many pixels you're trying to render. So doing this on a part of the image or just zooming out on the image will make that all go much faster. You see, we got a lot more brightness out of these guys. It's still not what I would call, good room illumination, but we do have control over the brightness of a type of fixture. If I wanted them bright, these same fixtures bright at the middle of the room, and let's say dimmer around the perimeter, I would then have two types. I would have whatever this one is, lighting fixture, recessed can. I would Edit Type and rename this to be 200 watt, or just say bright. Okay, and then I'd copy that over here, duplicate it, and have one called dim that was 50 or 60 watts, something like that. So that the brightness goes with the type. It's really just like changing the dimension of a chair or a desk, just using a type parameter to change a bunch of things globally. You do that with a type. So initial intensity. Let's look at the initial color temperature. Let me paint this floor white just so we can see the color temperature change. This clad white is a good one. So this sort of this warmish round yellow glow from these light fixtures, the way that they're set up right now. And that's because when we go to Edit Type, down here, the color temperature is set very low, just what a dim incandescent bulb will do, and sort of lighting that scene. If we crank it up to, I use this one, D50 or 5,000 degrees Kelvin. So just seeing the difference there. 5,000 K, apply, okay, render. So a whole different feel. Maybe 2 years ago, a lighting engineer came in to speak to the juniors, including about lighting for hospital operating rooms, where what was called for was the opposite of warm brown color light. They wanted a very blue light so that veins would show up really well. if it was warm light, there wouldn't be that much distinction between the skin and the blood veins inside. With blue light, the red of the veins really pops out and looks almost black. So there are real reasons for doing that beyond just ambiance in a restaurant, functional reasons as well. It's a good one. Okay, we can also add a color filter to any of these. Let's just add this guy. Apply. Okay. Even in Revit, which is not the greatest of illumination engines, you can do if you have a couple of blues over here and a couple of purples over here and aim them, they combine and cross. It looks really good. Now you notice something here. You notice that they didn't change right here. What these are, this is where I get down to page 2, called cheating. As we look at these guys again, this recessed can fixture, and let's say it's just made up of a reflective metal inside, and it's set up as a spotlight, which means that its entire field that it's illuminating is just from here to here. It's not, this bulb is not even lighting up that side of the inside of the can. I mean, we do have omnidirectional light sources, but there's nothing in there to make it look like it's glowing. So what Revit does is it puts in a disc, 1/4 inch thick or something, and applies to that the material called glass high luminance white glowing. So it's just a glowing thing that doesn't shed any light, but doesn't block any either. So the purple light comes through it just fine, but it itself keeps glowing white. So if you wanted to do that, if you knew you had purple and blue lights, you could make a whole new family for blue lights and purple lights and change the material in the blue lights to be blue and the material in the, it would get a little complicated. Could be done. It'd be a fun project to have somebody paying you to do. So there's a lot possible, but right out of the box, it's sort of bog standard stuff. And as we go through these, I've got some questions at the top of page 2 to sort of the basic lighting design questions that really you should think through, at least to this level, for pretty much every room you do, which is, what kind of light do we want? Let's say in a studio situation here. Dark, dramatic light, dark contrast with islands of light in a pool of darkness. Now, the sculpture people might really want to have that somewhere in their program, where they can put something on a rotating table and see it in all kinds of light. Graphic designers, no, they're going to want it just as, they want a whole wall that's completely evenly illuminated. Evenly medium bright with accent or task lighting here and there, like in a library, perhaps. You certainly don't need super bright in the stacks, but you want to have good light where you're sitting and working. Uniformly bright anywhere, like an operating room. They don't want any shadows anywhere. And what kind of fixtures do you want to use the space to see? Exotically colored and sculpturally shaped? I don't think of those in terms of Schneider Hall somehow, but maybe it's time. Classy but unremarkable or forgettable? I would say these are certainly forgettable. In the graphic design room, sort of the one off to the right, they have some really nice light fixtures. It's like 50% up and 50% down. So it's really nice for computer work. So you don't get glare, but you get good light. Back to the color filters, you can just take that white glowing material, duplicate it, and change it to a red glowing material. That would be a separate type. Oh, okay. So you don't have to remake the family. Okay, if we're doing this, glass white high luminance, I don't want that. But I'm going to take that and duplicate it, duplicate material and its assets. I always like to just do that cleanly. Yeah, let's see. Okay, its color is not quite true white. Let's just crank this one up to red. Okay. Be in a dark room. Let's see if we get it first. But why isn't that showing up? I know. That's what my question is. So that's the generic appearance. Generic. Okay. Maybe I have to go instead of that. Maybe I have to go to tint. Okay. There we go. Okay. Wow. Okay. So tint as opposed to whatever that was. Well, let's try it. Let's try it. Okay. So that's apply that to that. Okay. And I need to rename that to be, it was just the copy glass. Rename red. Red high luminance. Okay. So it's still transparent, light's still going to come through it, all that kind of stuff. Okay. Apply. Some of these, something is wrong here. Oh, I have to rename it out here is where I have to do this. Edit. Oh, sorry. Red high limits. That's good. Okay. Okay, well, there we go. Apply. Okay, let's try. So now these are, I need to change these really so that they show red light instead of sort of that purple light, right? Edit type. Where did I show? What did I show? That wasn't. There's a lot of blue in there. Let's pick the same color and apply. Okay. Ooh. Okay. And so now we need to. Yeah, I just going there. Artificial only. Render. Whips and chains and manacles on the wall. Who knows what's all going on there. Or a dark. Okay. Well, that was good. So y'all never forget that. Okay, a couple things. Now let's imagine we wanted those to be. I want to make these very hard, tight spots so we see circles on the floor instead of sort of this generalized thing. So again, we'll pick these. And now I need to go to, well, let's see, let's go to edit type. Okay, we have 3 angles here that we can attach to any of these that are made with the idea of a spotlight, and we'll get into that in a minute. But the first is the tilt angle. Do we want it aiming over this way instead of straight down? So straight down is 90, and I forget whether this is 45 or minus 45, but you can play with that. And there are 2 angles here. And the first one is called the field angle, outside of which there's no light at all. The other is called the beam angle, and that's tighter and inside. And so it'll be full brightness inside of here, and then gradually slow down to nothing by the time you get to the edge of it. And if those are almost the same, you get a sense of, boy, that's just straight down. If they're quite different and the field goes out like this, and the angle's in the middle, it'll fade out very gradually. So let's change the field angle to, that's the big one, let's say to 20 degrees, and the spot angle to 15 degrees. So field spot. Okay, RR. So that sort of a look. And I guess if you make them the same, let's just try that for a second. Make these the same angle. See how sharp a joint we get. An edge. Well, that's a bit unexpected, huh? I don't know why that, maybe this has to be a little bit bigger. Field angle, make it 16 degrees. Apply, okay. Not all the light sources have this. This is only for the ones that are true point light sources that let us, okay, so that's about as tight as it gets. That's pretty hard edged. So this is a good time to explore the 4 kinds of light sources Revit provides. And I guess the easiest way to do it is, let's go back to this guy again that we know and love, and edit the family. And just get into a elevation view. So here's the light source, and we can see the default beam angle, which is 90, and the spot angle, which is I guess 30. That's just the way it would come when you load that the first time. The light source itself, when we pick it, we get this option up here related to just the light itself. We have these 4 different shapes of the point that we've been dealing with, which is the one that can create a focused beam with an edge. We have linear ones that are like fluorescent tubes or under cabinet kitchen incandescent lamps. We've got rectangles, which is how they're modeled for these. We're not modeling that as 3 or 4 tubes. We're just treating it as a big flat rectangle emitting light evenly, and the same thing with the circle or the LED light fixtures that are very thin, just a glowing disc. That would certainly perfectly modeled with that. And then for each of those, we have the 4 possible ways of distributing the light. One is evenly in all directions, a glowing sphere, like the sun. It just shoots in all directions evenly. This falls off with the inverse square law, just like real light sources do. We have this one hemispherical, where I guess we can see those, where the actual point light is treated as if it's a larger half dome radiating light. We've got this, the spotlight. So this point light source combined with the idea of a spot, an aimable spot. And then lastly, and more of them are like this is what's called an IES profile from the Illuminating Engineers Society. And they have compiled basically a file for each lamp in each light fixture that manufacturers submit, and it measures the actual brightness values around that. And that gets projected out to whatever it's hitting. If the glass is a little bent and you get some diffraction or concentration, it will be picking that up as well. That's the most accurate one that we have. If you want to get a little preview of what those beams are going to be like, in Properties Visibility Graphics for this view, for the view visibility graphics for lighting fixtures, we can turn on this thing called light source. Apply, okay. And then we will see previewed in yellow the cone of light that those guys will be putting out. Let's see it with some other fixtures and see a difference. So I think I'll just go back into my ceiling plan view and put a couple of just troffer fixtures in here. Troffer 2x4. Drop those puppies in. Well, you can see there's sort of this the bottom half of a suitcase or something rather that gives a sense of what that light distribution is like. But one of the things one real reason to have Enscape compared to this is that Enscape is doing all this re-rendering as soon as you place the light fixture. You split your screen in half and there's Enscape running here or on a separate monitor and Revit running here. And these just happen like right away. So that's not quite as interesting a look, I confess, but that's what you get when you mix very different light sources. So let's say that this is the Halloween haunted house, and they want to be able to switch the red lights on separately from the white lights. So on Friday and Saturday nights, the red light is on scaring people, and the rest of the time the white light is on so they can come in and mop or whatever they have to do. Let me put in one or two more light fixtures. I'll move them back here so they're in view. And because what we have in Revit is the ability to assign light fixtures to groups that can be turned on and off and dimmed separately. This is a nice way to have fixture groups be relatively dimmer or brighter without having to go into edit type and changing the whole thing. So typically, actually, it's just a dimmer. It just makes things dimmer. It doesn't make them brighter. So I usually start out with a bright light fixture, like 200 watts. And then if I need to tone it down for rendering, I can control my blue lights separately from my red lights just with their sliders for that. So let me show you how that works. We have to go into the rendering end of things, RR, to do that. Oh, I can't render in this view. I got to get into this one. RR. Over here, we've been picking what of these do we want to show? Interior, exterior, artificial sun, or some combination. We have sort of the same thing here with artificial lights. When you first place light fixtures, they're not grouped at all. I would like to group the troffers on one dimmer and group the red downlights on another one so I can control them independently. Even like turning the troffer ones off for a rendering when I want to show it just looks like a House of Horrors. So I'm going to create a new group called red spots. And those are all these downlights. Can I just drag it up there? Oh no, I have to do this and pick it. I have to pick them. And with this red spots, I will then go into edit. And here I can pick the lights that I want to go into the red spots group, all my red spots, and I'll say finish. Save the project. Sure. Lighting. And I realized I have a bunch of, there are a couple of weird lights out here in my other ceiling plan. I'm going to get rid of this whole group over here so I don't confuse things. So go back to render, sorry, 3D view, RR for render. I wish this were available somewhere else, but I haven't seen it anywhere else. I've since discovered that when you select one or more lighting fixtures in any view, you can assign them to a light group on the options bar. So I got my downlights are all in the red spots group. I'm going to create a new group called fluorescence. Even though they probably aren't, I still think of them fluor. And I'm going to pick the fluorescence group and edit that and pick these two to add to it. I'm done. So now when I go to render, I can choose which of those groups I want to see. Right now, I don't have any that aren't yet part of a group. They would just like, you can almost treat them as another group if you like. But let me turn off the spots to start with. And we'll see just fluorescence. So there's sort of a warm fluorescent, whatever that color temperature is. And that's that. Okay, so let's do it again with, here we are right here. I'm going to turn the spots on and turn their fluorescence off. There they are, RR. Oh, it looks to me, since these guys, the fluorescents also have that glowing high luminance white stuff. How are we going to turn that off? What's an easy way to do that? Well, I don't want to make any like huge changes, but let me edit type. I could just change glass white high luminance, like to change it to air. Let's change it to air. Let's see what happens. Okay, so they're not only not shedding any light, they're not glowing. That's a good trick. Let's see what happens if I render them without that glowing rectangle. Artificial lights. So yeah, see, that's what's happening, is that they are illuminating the room, but don't appear to be. But you can see why you need to put that in there. Those lights are aiming down. They're just not hitting the rest of the inside of that light fixture, even if it was reflective enough and light enough to work. Well, so it's doable. You notice that our red lights are really red right now. They're really glowing. So it's not a perfectly malleable lighting solution. I know people in the theater thought this would be great and then decided because of lighting, it just wasn't flexible enough for their needs to show how lighting fixtures really work. So let me turn that back. Turn that stuff back on again. How did I do that? Edit type. Yeah, change that back to the high glass. Okay. Oh, wrong one. Okay, bye. I'm about done for the day, but I do want to introduce you to this website, ies.org, for the Illuminating Engineering Society, which can provide a lot of good information about how to design for different types of facilities. And one thing it'll be giving you is a lot of recommended illumination levels for different activities. Like, fine dining restaurant might be quite dim, except for on your table where it's moderately bright. Operating room, very, very bright. And something that we can do with the online rendering. You render in cloud. In addition to be able to render just normally, Revit on the cloud can also give us a illuminance map. Let's just use that. where it will give us false colors, but keyed to brightness levels. And typically on a desk, you'd want 50 foot candles or something. Oh yeah. Oh, old projects. This is great. So it gives us a scale of foot. I think we're doing foot candles. So we'd sort of like to be looking for green on a desktop, which was the 50 or 60 foot one. We can see right away we have really different luminance values on the two desks. So we want to even that out. And with the sun turned on, it would be giving us adding that in as well. This is good stuff to have in your projects. Looks like you paid attention to things. And actually, if you do get similar levels of lighting on similar places where people are working, you have started to do a good job. And what's taking the time is it's tracing lots of light bounces around to see how they add up and sort of gather on a given surface. This is basically saying 200 foot candles is just way too bright. That would be blinding. That would be, operating room levels of lighting. If you've taken the effort to realize, well, if I had 4 desks here and one was blue and one was red and one was yellow and one was green, I haven't really done a good, classroom or office design. And one thing you want to avoid, these really bright ones, is you can see what the kind of contrast we're getting of the fixture against the ceiling surface. Over in graphic design, it's nice because they're suspended 1.5 feet or something, and they light the ceiling. So you've got a glowing ceiling that's giving you light as well as the downlights. My lighting design professor in graduate school, he called the recessed can fixtures ceiling acne. And that's just how he felt about them, that they were little high contrast zits. He had to use them, from time a lot probably, but was always trying to do something more interesting with them. I think what you want to avoid in any place where people are spending a lot of time is great contrasts. A lot of times when you get a light fixture over against a wall, just because of where it had to be because of the ceiling grid or something, you get a big glowing swatch on the wall that really doesn't need to be there. It pulls your attention. It makes your irises contract so that everything else looks dimmer while you're sort of accommodating to that. So this is pretty terrible lighting for an office. It's not bad for a dungeon. Anyway, that's what I got.